So let's see angular momentum matrices. So we'll just see Jz, J square, J plus J minus and thereby Jx, Jy matrices form. So how to derive those matrices, that one you are going to study. So the matrices J square and Jz are diagonal matrices. So these are diagonal matrices. So why they are diagonal, that one we'll see now. Jz is equals to mz h cut. That is, when Jz operator acts on a wave function, it would give the same wave function multiplied with its eigenvalue mz h cut. And why it gives mz h cut only means, if we see mz is just a number, it's just like a constant, it does not have any units, and h cut, so wherever we see we would have h cut. So Jz has the units of MVR, that is just like angular momentum. In the same manner, h cut also has the units of angular momentum. So we know that E is equals to h mu. So E is equals to h mu. Mu is nothing but one has the units of 1 by t, 1 by that of time. So that is nothing but energy into time. So if we consider, so if we think energy means force into displacement, and next multiplied with time. So we already know force is nothing but ma, v by t. So tt would get cancelled, so we would have mvr, like that. So that's why we would have h cut, and in the place of j square we are having h cut square. So the reason for taking h cut is, of course we used to take in some of the cases h cut is equals to 1 unit, like that, but this is very important because it has the dimensions of angular momentum, as Jz has the dimensions of angular momentum. So for balancing the dimensions also we would have h cut in the formula. So forgetting h cut is not good. Of course in some of the cases we would take h cut is equals to 1 unit. It does not mean that the dimensions are 0 there. So that is the thing. So Jz operating on the eigen function would give us the same eigen function multiplied with its eigenvalue. So eigenvalue of Jz is mz h cut, and eigenvalue of j square is j into j plus 1 h cut square, just like the eigenvalue of L square is L into L plus 1 h cut square. So that derivation is also given in this channel, you can see that videos also. So these are the eigenvalues of Jz and J square. So with the help of these eigenvalues formula only, we are going to derive these matrices J square Jz matrices. So the value of angular momentum number mz varies from minus j to plus j. So this point, the proof for this point had already been discussed in allowed values of angular momentum. So there finally you can find that j can have values from minus j to plus j, like that. So mz varies from minus j to plus j with the interval of 1, and total values of mz will be 2j plus 1 values. So just like for L value is equals to 2, we have minus 2, minus 1, 0, 0, 0, 1, 2, 5 values. So 2 into 2 plus 1, 5. So based on that formula, here also same thing. So 2j plus 1 values, and hence the dimensions of these diagonal matrices will be, so the dimensions they are saying, that means 2 by 2, whether it is a 2 by 2 matrix, 1 by 1 matrix, 3 by 3 matrix, like that. So here the dimensions of these matrices is given as 2j plus 1 by 2j plus 1, 2 by, just like 2 by 2, here 2j plus 1 by 2j plus 1 matrices. That is, that matrix, angular momentum matrix, would have 2j plus 1 rows and 2j plus 1 columns. Why to only 2j plus 1 rows only means, for a given j value, m has 2j plus 1 possible values, 2j plus 1 possible m values. So these, for these many m values, we would have these many rows and these many columns. So that is the first thing. So here you can see the form of these matrices. So first of all, let us see this Jz matrix. So it is h cut multiplied with this matrix. So as I have said, h cut has the units of angular momentum. So must be there. So this matrix is just consists of number. It does not have any dimensions. It has the units. So that is the thing. And h cut multiplied with these matrices. So as we already know, constant multiplied with a matrix. Suppose k is multiplied with a matrix such as a square matrix, 2 by 2 square matrix, A, B, C, D. Then what we would have? K into A, B, C, D matrix. That is Ka, Kb, Kc, Kd, like that. So here in the operation of Jz, operating on that eigen functions, we would have many eigen functions. So it would give j h cut, j minus 1 h cut, j minus 2 h cut until minus j h cut, because eigenvalue of Jz is m h cut. So here in one of the wave function, j is the m value. In another wave function, j minus 1 is the m value, and again j minus 2. So these are the possible m values. So m h cut, all of them multiplied with h cut. So h cut could be taken as common, and this is that matrix. So just like a constant multiplied with a matrix gives us Ka, Kb, Kc, Kd, like that. So like that. So here constant reverse process we have done. In every case we would have h cut like that. So h cut could be taken as common. And when the value is 0, 0 could be written as 0 into h cut. So that's why we could take h cut as common and we could represent. So this is the matrix, Jz matrix. So why it is so, we'll see in few minutes. And J square matrix. J square has the units of angular momentum squared. So h cut square multiplied with j into j plus 1, j into j plus 1, j into j plus 1. So when j square operates on the given wave function, so j square operates on psi of jm wave function, it would give j into j plus 1. And j square operates on psi of j comma m minus 1, it would again give j into j plus 1. And again this j square would operate on psi of j comma m minus 2. So whatever is the thing, we would have j into j plus 1 is the only eigenvalue of j square into j into j plus 1 into h cut square, because for a given L value there are many possible m values. For a given L value, particular L value, there are many possible m values. So j square would have all the same values. So this is the matrix form. So remaining all the elements, only diagonal elements would be present, remaining all the elements would be 0. So both of them are diagonal matrices. Why it is so, we'll discuss in a few minutes. So for j equals to 0, so when j equals to 0, these are the values. Jz is 0, because for j equals to 0, the only possible m value is 0. So m h cut, 0 into h cut, 0. So we would have 1 by 1 matrix. Another important thing is here only one m value is there. So 2j plus 1, 2 into 0 plus 1, 0 plus 1 is nothing but 1. So we would have one all together 1 by 1 matrix. So for j equals to 0, we would all get 1 by 1 matrix based on this formula, 2j plus 1 by 2j plus 1 matrices. So 1 by 1 matrix, and that 1 by 1 matrix for Jz is 0. 0 into h cut is nothing but 0. And j square is nothing but j into j plus 1 h cut square. So 0 into 0 plus 1, 0 into anything is 0. So this is also 0. And j plus, we already know eigenvalue of j plus is square root of j minus m into j plus m plus 1 into h cut. So as here j is 0, m is also 0, so j minus m is nothing but 0 minus 0. So 0 into anything is 0. Here also, the eigenvalue of j minus is square root of j plus m into j minus m plus 1, h cut into h cut. So there also j plus m, 0 plus 0, 0 into anything is 0. So all these are all 1 by 1 matrices. So this is not just bracket, inside bracket 0. So all of them are 1 by 1 matrix. So 1 by 1 matrix has one element, only one element. So 1 row, 1 column. So one row, 1 column. So 1 by 1, all of them are all, they are not just brackets, they are 1 by 1 matrices. And next, now coming to next value of j, that is half. Now 2j plus 1 is nothing but 2 into half 1, 1, 1 plus 1, 2. So we would have 2 by 2 matrices for this. 2 by 2 matrices, and those matrices are this. These are the matrices, and this form of matrices we would derive now. So how these matrices are derived, we will see now. So these are those 2 by 2 matrices for j is equals to half. And next thing is, let's see so this form, so that we can get a clear idea. So this is the general form. So each of the matrices Jz, J square has the form. So Jz, J square would have diagonal, they are all diagonal matrices. So only diagonal elements would be present. So element present, element present, element present. So here you can see the form. So here we would take into consideration J value, M value. So for one of the eigenstate on which the operator is operating, and this is another eigenstate on which upon that operator is getting multiplied. So that is here you can see. So j values, these are j values: 0, half, 1. For a given 0, m value is only 0. 2j plus 1. 2 into 0 plus 1, 0. And for half, 2j plus 1. That is 2 values. That is plus half to minus half, ranging from minus j to plus j with the interval of 1. So minus half plus 1 is nothing but half. And next is 1. When j is equals to 1, m values. 2j plus 1, that is 2 into 1 plus 1, 3. We would have 3 m values, 3 possible m values, ranging from minus j to plus j, minus 1 to plus 1. And minus 1 plus 1 is 0, 0 plus 1 is 1, the interval of 1. So these are the possible values of m. So based on this form, for here also 0, 0, half minus half, and 1, 1, 0 minus 1, like that we would be having. So here we would take j value, m value, here also j value, m value we would consider in the matrix form. So by doing that, after operation we would have this only principal diagonal elements, remaining all elements would be 0. So hence Jz and Jsquare matrices only contain principal diagonal elements. So now let us see how is this possible. So let's first see how Jz and Jsquare matrices are possible, and then J plus and J minus matrices, thereby Jx and Jy matrices we would see. So how is it possible? So now first let us derive this matrix, this Jz matrix, h cut by 2, 1, 0, 0, minus 1. How is this possible? Then J square matrix. Then finally we'll go to J plus and J minus matrices. So any matrix element of Jz could be written as matrix element of Jz matrix is, so bra J dash M dash and Jz Jm operating on Jm. So this is the matrix element of a Jz matrix. These are all the matrix elements. So what is the mean it would give us, what does it would give us is, so this is nothing but this could be considered as, first of all, this part is nothing but Jz operating on wave function xi of j comma m. So what does this give us? So m h cut. So here m is this, it does not do anything. So m h cut xi of, it would give again the same wave function. Jz operating on wave function would give us the same wave function multiplied with its eigenvalue m h cut. So that is this part. Next what we have to do is now this part. So that is nothing but this is bra and this is ket. Multiplying this with its complex conjugate and integrating. So that is nothing but mh cut xi star jm xi jm and integrating over the entire space. So here mh cut is nothing but constant, could be taken out, and integration of xi star d tau is nothing but 1. Sorry, so it would, so here we are having j dash m dash, so this one could be 1 or 0. That's why we were having some of the matrix elements 0, based on whether so we already know orthogonality condition, that is xi I xi j integration d tau is equals to 1 when I is equals to j, and equals to 0 when I is not equals to j. So if these two are two different wave functions, then we would have the value 0. If they are the same, then it could be 1. So how we could represent it is with the help of this delta function, Kronecker delta function. Delta of j dash comma j, delta of m dash comma m. So what does this mean? So when j is equals to j dash, Kronecker delta would be 1. When m is equals to m dash, Kronecker delta would be 1. So finally we would have mh cut only when j is equals to j dash and m equals to m dash. And when j is not equal to j dash, Kronecker delta would be 0. Or else when m is not equal to m dash, Kronecker delta would be 0. So entire thing would be 0. Or else when when both j is not equal to j dash, I mean m is not equal to m dash, when both of them are not equal, then also we would have 0. So based on these conditions, we could have eigenvalues, that is matrix elements, non-vanishing matrix elements and vanishing matrix elements. So this is the main condition we need to keep in mind. So entire matrices we are going to derive is based on this condition. So this one we need to keep in our minds. So for now, let us derive Jz matrix for j value is equals to half. So this is the simple equation, simple matrix, that is 2 by 2 matrix, which we have seen before. So we are going to derive this matrix now based on this condition. With the help of this condition, as now I have explained. So by making use of this condition, we are going to derive Jz matrix for j is equals to half. So first of all, we need to, so this is a Jz matrix. So jm, so j goes from here and m goes like this, and if we write in this manner, so on the top j, on the bottom m's, and here on the left hand side j, on the right hand side m's. So like that we could get. So now if we write, so j value is half. So for this value, we are having two possible m values, 2 into half plus 1, 1 plus 1, 2. That is minus j2 plus j, that is half minus half. J value is half. J value half, j value half, m value half minus half. So this is the situation. Now these are or else we could write it as, this is jm and this is j dash m dash. So like that, this is the best way to represent. So this is j, this is m, this is j dash, this is m dash. So actually they are all the same. So here j, here j dash, here m dash, they are all the same. So just to indicate this Jz operating on this wave function, and again getting operated by this conjugate, multiplying with its with conjugate of some function. So like that, this conjugate could be some other function or this function also same. So when that conjugate is same as of the same of this function, then we would get 1. So that one let us see now. So first of all, first element, this is first element. So first element of the matrix is nothing but, if we see, so j dash m dash half comma half and jz operating on half comma half. So this is first element. So these are j dash m dash and this is jm. So jm is half half. Now based on this definition, first of all, what does this mean? Jz operating on this wave function giving mh cut and multiplying with its complex conjugate. Next step. So when Jz operates on this wave function, it would give us mh cut. Here m is this jm half h cut. And next thing is, this is the wave function. This wave function multiplied with its complex conjugate of this wave function. So that is nothing but we would have xi of half half star into xi of half half d tau. So here if we see this, here j is half, here also j dash is half, here m dash is half, here m is half. That is j is equals to j dash, m is equals to m dash in this case. So this entire thing would become 1. So hence we are having half h cut. So this first element would become half h cut based on this condition. And next, if we see next case, next element, here in this for this element, j dash m dash is half half and jm is half minus half, half minus half. That means j dash m dash half half for the next element, and jz operating on jm is half minus half. So what does this give us? So here m value is minus half h cut, and integration of xi star half comma half and xi of half comma minus half d tau. So here if we see, j is equals to j dash and m is not equal to m dash, because here m dash is half, here m is minus half. So here the difference comes. So delta m comma m dash equals to 0. So this half h cut multiplied with 0. Even though delta j dash is equal to 1, but delta m dash is 0. So 1 into 0 is 0. Anything multiplied with 0 is 0. So even though j is equals to j dash, we are not having m is equals to m dash. Because of that, half h cut into 0, that is nothing but 0. We could write it as 0 h cut. And for the next element, so next element also same process as here. You need to consider the same process. So in the case of m dash, you would have half minus half for this element, and in the case of jm, you would have half comma half. As you could see here, j dash is equals to j, but m dash is not equal to m dash is minus half, m is half. So here also based on this Kronecker delta function, here also element would be 0. And finally next element, in the next element, j dash m dash is half minus half for this element, and jm is half comma minus half. So in that next element, if you could see, j equals to j dash, so j half, j dash minus half, sorry, j is equals to half, j dash half, and m minus half, m dash also minus half. So j equals to j dash, m is equals to m dash. So this condition would be happening, and here m value is minus half, so m h cut, so minus half h cut into integration of xi star xi d tau would become 1. So you would have minus half h cut. So this is the Jz matrix. So this, hence Jz is equals to, we are having, so we could take h cut by 2 as common. H cut by 2, if we take as common, h cut by 2 into 1. And this is 0 could be written as h cut by 2 into 0. So again 0 would be there. Here also 0 into h cut by 2, that is 0. And h cut by 2 is taken common, minus 1. So this is the Jz matrix. So h cut by 2, 1 0 0 minus 1. So which is same as this h cut by 2 1 0 0 minus 1. So hence we have derived Jz matrix. So next what we need to derive is, so this h cut in the same manner there are many Jz matrices here for different values of j. So this is the Jz matrix for j value 0, and this is the Jz matrix for j value half, and this is the Jz matrix for j value 1, and this is the Jz matrix for j value is equals to 3 by 2. So that is the form. Here Jz by h cut is taken actually here. So y means if we send this h cut this side, Jz by h cut, here half is there. If we take the it inside, half into 1 half, half into 0 0, half into 0 0, half into minus 1 half, minus half. So half 0 0 minus half. Hence we are having half 0 0 minus half. This is nothing but Jz by h cut matrix. So that's why we are having half 0 0 minus half. So these are the matrices required Jz by h cut matrices. Jz divided by h cut. So this is 1 by 1 matrix, this is 2 by 2 matrix, as there are 2m values, 3 by 3 matrix for 3m values, 4 by 4 matrix for 4m values, corresponding 4m values. So for j equals to 3 by 2, minus 3 by 2 to plus 3 by 2, minus 3 by 2 plus 1 minus half plus 1 half, 1 half plus 1 3 by 2. So hence we are having these matrices. So minus j to plus j to minus j. So plus j 1 0 minus 1 m values. These are the m values. 3 by 2 half minus 3 by 2. These are the possible m values. So hence we are having principal diagonal elements, only principal diagonal elements. And here as m value is 0, that's why we are having 0 in the principal diagonal element. So overall if we see, we are having only principal diagonal elements, remaining all the elements are 0. So this is the form of Jz by h cut matrices. And next thing is, next let us derive this J square matrix. Let us see how to derive this J square matrix. So for the J square matrix, we are having simple equation, that is J dash M dash bra of J square and ket. So this is the form. So in order to get J square matrix, we should have this form. So let us see. So for j is equals to half, if we consider j is equals to half, same thing. So jm values half half, j has half values, and m half minus half, and j dash m dash values, j dash half half, m dash half minus half. So the same procedure. So j square are operating on j comma m. So we know that eigenvalue of j square is j into j plus 1 h cut. So here what we would have is, so first of all, first element is half half. So the half, j dash m dash half half, and jm half half. So j square half half. So if this operates, what we would have, j into j plus 1 h cut. So j, here j is this half. Initially we have taken m values, now here only j value. So half into j plus 1, half plus 1 h cut, and so this one operating on this one would give the same wave function, and this function multiplied with conjugate of this wave function. So if we see same as here, that is xi star of half half, xi of half half, half comma half t tau. So this integration is nothing but 1 when, because j equals to j dash equal m dash m equals, so both the Kronecker deltas would be 1. So this one would remain. So half plus 1 is nothing but 3 by 2. 3 by 2 into 1 half is nothing but 3 by 4 h cut. So hence the first element would be 3 by 4 h cut. In the same manner, next element, if we see here j dash j values are set, but m is not equal to m dash. So one of the Kronecker delta would become 0. So because of that, this element is 0. And here also the same, j equals to j dash, but m is not equal to m dash. So here it would become 0. And in the next case, if we see next case, half minus half, j square, half minus half. So in this case also, j square does not depend on m value, it only depends on j value. So here also the j value is half, so half into half plus 1 h cut, and here j equals to j dash, that is half, and m is equals to m dash, minus half, hence Kronecker deltas would be 1. So this is the final. So 3 by 2 into half, that is 3 by 4 h cut. You would have same 3 by 4 h cut. So the j square matrix is 3 by 4 h cut 0, 0, 3 by 4 h cut. That means, h cut square it is. J into j plus 1 h cut square, that is the eigenvalue. So j into j plus 1 h cut square it is. H cut square. So as I said, j square has the dimensions of angular momentum squared. So h cut squared. So this is the matrix. So hence we are having 3 by 4 h cut square 1 0 0 1. So we need to just take 3 by 4 h cut square common. If we take it, you will have this matrix. So that in this manner we could get j square matrix. So in the same manner, we could consider the j plus and j minus matrices, eigenvalues of j plus and j minus matrices. So by finding those eigenvalues and those matrices, we can find these jx and jy matrices also. So this is one of the form of j square matrix. So if we see here, so this is the various j square matrices for different values of j. These are all the possible. So this is the 1 by 1 j square matrix for j value equals to 0. And this is 2 by 2 matrix for j value equals to half. Just we have derived now. So actually here it is taking j square by h cut square. So y means this is j square matrix. So h cut square could be taken as common. So h cut square into 3 by 4 0 0 3 by 4. So j square by h cut square you would have 3 by 4 0 0 3 by 4. So that's why we are having 3 by 4 0 0 3 by 4. So for this is the for j value is equals to half. In this that is nothing but half into half plus 1 is 3 by 4. And next for j value is equals to 1. That is 1 into 1 plus 1 2. So h cut square. And next j value is equals to 3 by 2. 3 by 2 into 3 by 2 plus 1. So 3 by 2 plus 1 is nothing but 5 by 2. 5 by 2 into 3 by 2. 5 3s are 15. 15 by 4. So these are the eigenvalues. So for every the j value does not change. So only we are having different m values. So hence these are the matrices 3 by 3, 4 by 4 matrix for different possible values of j's. So this is the jz and this is the j square matrices. So here we could see that only principal diagonal elements are present. Remaining elements are all 0. So here also. So that is about jz and j square matrices. And we will derive jx and jy matrices with the help of j plus and j minus matrices, and it would be continued in the next video as the video has become lengthy. So how to derive these jx jy matrices, and from the j plus j minus, first we need to find out j plus j minus matrices, then jx and jy. So that is the special case we would get upper and lower diagonal matrices. So that would be continued in the next video. So that is regarding jz and j square matrices. So thank you.